All right, so this is a problem we had in our homework packet. And I'm going to go ahead and solve it by actually drawing free body diagrams for each object. So first, we've got M1, there's a normal on it. There's its weight. There is friction. Whoops. Let's do that again. There's normal. There's weight. There's the tension on it. And there's friction going backwards. And for mass number 2, we're going to I'm going to draw a dotted line here, and we're going to have F that points at an angle theta. We're going to have the normal 2 on it, the weight, its own weight. We're going to have tension going backwards, and we're also going to have friction. And I'm going to put a little subscript 2 here and a subscript 1 here. So this is what we're dealing with. Now, given this fact, what I want to do is set up equations in the x and y for each of these. So first I'm going to have the tension competes with the friction, but mass 1 still accelerates. And of course here, because we only have normal and weight in the vertical direction, I can do a little calculation here. Normal and weight balance, and so I'm going to get that friction is mu times m1g. So I'm just going to go ahead and do that substitution right now. Tension minus mu m1g equals m1a. Perfect. And now for m2, the story gets a little bit more complicated. In the vertical direction, I'm actually going to write that equation first. I'm going to end up getting that the normal cancels with the weight and with the vertical component downwards of this applied force. And so what this means is I can set up my equation in the horizontal direction as F cos theta minus the tension minus the friction on the second object, and that equals m2a. And when I actually simplify here, I'm going to get F cos theta minus T minus mu, and now I have the normal force, which is going to be F sine theta plus m2g. And that whole expression, which I think I want to move over just a little bit so that we can read this solution later. And that whole thing is going to be equal to m times m2 times a. So here are our 2 equations written on the next page. And what I want to do is I want to go ahead and solve for tension. So there's a little trick I'm going to do here. I'm going to multiply the equation on the left by m2 and the equation on the right by m1. And that means the right side here is going to equal m2 m1a, and this side here is going to equal m1 m2a, and we can set these two left sides equal to each other. When I do that, and that's going to give me m2t minus mu m2 m1g equals m1f cos theta minus m1t minus mu m1f sine theta minus mu m1 m2g. Now we get lucky because this cancels with this term here, and I can do a little bit of simplifying, and I'm going to end up getting m1 plus m2t equals m1f cos theta minus mu sine theta. And finally, I can simplify my tension to be m1f cosine theta minus mu sine theta divided by m1 plus m2. And I can go ahead and plug in all my numbers.